there's only like 8 of you in here, so
Yeah.
we don't need everyone muted. It's a lot easier to talk. So yeah.
All
And
right.
honestly, yeah, if you guys want to put your face cams on and all that stuff, this is a lot more interactive than the other one. So everyone, unmute yourselves, put your cameras on, and let's have a workshop.
All right, cool. So recording's on, and we can go ahead and begin. If you haven't typed in the phone box discussion yet, you can do it at any time. And we're just getting those down for next time. So today we're going to be going over a quick overview of sorting algorithms and program efficiency. So I'm going to start sharing my screen. You should be able to click on the live stream and see it. So go ahead and do that. So get all in. Just wait for everyone to load. Alright, cool. So it looks like we got everyone in. My Discord's kind of unstable right now, so if I leave the call, I'll be right back. It's just crashing on me. So, um, is anyone familiar with sorting algorithms or algorithms in general? Alright, no worries. So, um, in computer science, we have multiple ways of achieving the same end goal, but not all of them are equal. Just as it's faster to drive than walk somewhere, scientists have created special algorithms for us to make processing as fast as possible. And it's important to know these so you can maximize the efficiency of your program. Um, but before I get into it, I just want you to try and sort this list of numbers out for you. So you got 2, 1, 4, 3, 1. I just want you to sort these so they're in ascending order. Just like do it in your head, do it anywhere. Oh yeah, Rubik's Cubes, that's a great thing. A great analogy right there. Rubik's Cubes use algorithms just like programs. So try and sort these numbers so they're in ascending order. And you can type in fun box discussion if you want. You can say them out loud, whatever you want to do. Yeah. So 1, 1, 2, 3, 4 would be the sorted thing of it. 1, 2. Now, for humans and stuff, it's pretty easy to get this sorted, right? We can just check them. But can one of you who answered just explain how you got there, like the steps you took? You can unmute your microphone or. Because for us, we kind of unconsciously do it, right? We just come from here and get it straight to here. But how did you do it? Yeah, like I said, I just did it. But try and slow down your brain and think about what you're doing with this.
Well, what I would do is I would kind of put the duplicates together and then just put them in ascending order after I have all the duplicates together, just so that I don't erase anything or redo it.
All right, yeah, and that's good. Um, so yeah, what I was getting behind this, right, is how would you tell a computer how to sort these numbers, right? Um, as a lot of you are going to go into geometry either this year, next year, in a few years, you're going to learn how to kind of slow down your thinking and to go step by step through the problem more. So we have to go step by step on how we get this to here. So luckily, some very smart people in a very long time ago, in the 1900s, created different sorting algorithms for computers to sort these numbers for us. So, um, for example, with this, they would be able to get this in ascending order. Yeah. So, um, I'm not sure how you say your name, Udhenyan, if you can say it out loud so I don't mess it up. Um,
Dan,
what is it?
Dan?
Dan? Okay, cool. Yeah, so yes, you would sort it in numerical order, but how would you tell your program to sort in numerical order? Like, think about that, right? If you have to type out the code for it, how would you do it? So, to solve this problem for us, there's established sorting algorithms out there, and these include things such as bubble sort. Uh, you have things such as selection sort, insert sort, etc., etc. There's a lot of these different ones. And I want to make something clear for this, right? Is I don't want you to memorize these sorting algorithms. I don't want you to memorize the code, right? It's You're always going to have access to a computer whenever you're going to be programming. You always have access to the internet. So, you just want to understand why some of them are better than the others and what that means for your programs. So I'm going to show you a website right here. That's a good source. It's from the C programming website. So this is a little table of a bunch of different algorithms. I hope everyone can see it. So a good way to tell how good an algorithm is based on its big O notation. So as you go into AP Computer Science, you're going to learn more about this. But basically, inside this big O, you just want the number to be as small as possible. So if, for example, if you have 1, this is best case scenario. No matter what you do, it's only going to take 1 time to do it. There's also ones where it's O of n, and if you take an algebra, n is just a variable that represents the amount of elements in the array. So if you have, for example, 1, 2, 3, 4, 5, n would be equal to 5. And this is very abstract, right? There's not like, oh, it's going to take 2 seconds based on this equation. This just shows how the equation gets worse over time. So one of the most intuitive human ways to do it is called bubble sort. And a lot of you probably did it when we were doing the original equation. But this way is like very bad. It's impressively bad to do. It gets very slow. And you shouldn't, pretty much never should do this in an actual program. But there's always better ones that you can get. So you can see this is n squared. So if it's n squared, that means for each element, you have to go over every element again. So for this, you'd have to go over everything 25 times, which is not good. There's some better ones down here. So the 3 that you should usually be using is called heap sort, merge sort, and quick sort. These sorting algorithms are some of the best. They still have their quirks about them. For example, if you look here, this one can get pretty bad in the worst case scenario. This one's unstable, and by stability, that means that, for example, if you have 1, 2, 2, 3, a stable one will keep the order of these 2, but an unstable one may swap these. For normal use, this doesn't really matter, so you don't have to pay attention that much, but if, for example, you have something attached to it, it's going to mess you up. Right? But based on this, who likes math here, bro? Like, this chart's kind of boring. So there's tons of resources online. For example, this one that I really like called VisualGo, or VisualGo. And gotta exit out of this. That shows you the algorithms animated. So I'm going to be putting this in Funbox discussion. Oh, nice. I see you put that in. Yeah, you got the, great. Yeah, so PHP and a lot of programming languages actually have them built in. And that's a very nice reference, Eve. Thank you for putting that. Alright, so here we can see an example of the bubble sort algorithm, right? And if we go ahead and run it, what bubble sort does is it looks for each of them and just moves the greatest up to the top of the array. So you can see the 47 is being moved up, moving up. It just finds whatever's greatest and puts it at the back. And this works, right? This is usually what humans do whenever they're going through it. But it's very, very slow. Like you see here, just to do it, you have to go and go and go and go. And it takes a very long amount of time. We can speed it up. And for computer programming, you really want to avoid this at all possible. Some other ones, you got selection sort, which is where it does kind of the opposite, where it just brings it to the beginning, where it just finds the least value and then swaps them with the value it's currently on. So right now it's on 44. It finds the next smallest value, brings it to the front, and then continues. So just think about bubble sort, but backwards. And still has the bad performance issues, because for this it has to go through everything in the list for every element in the array. Not good. Next we get kind of faster. You got an insertion sort, which just inserts each element to wherever it's supposed to go. And this is faster. Still pretty slow though. Could get better. But the main takeout of this, right, is you don't have to truly understand how each of these work if you don't want to memorize it. When you do get into AP Computer Science, they're going to force you to memorize these. It's not going to be a fun time, but it helps you visualize what your program is doing. Now, so we see this, and there's tons of these, right? But one of the good ones I was talking about earlier is merge sort. So what this does is it splits it up and divides and conquers, and then merges it together. So you can see it split those two up. So merge those two, merges these two, and then merges these four. And this is actually very fast. It's made in the 1940s and still holds up today. So now because of this, I do strongly recommend you use merge sort in day-to-day operations, as it's just better. Although it's up to you which one works for you. You know, this is more heavy theory, and I know they aren't the funnest things to learn about, but it's important to have in mind how to write better code, right? The same thing, although it may reach the same conclusion, isn't going to have the same performance. And if you structure your way around by thinking not how can I get to the solution, but what is the best way to get the solution, you're going to greatly increase the quality of your code. Now, like I said before, I don't recommend memorizing these. There's no shame ever in copy and pasting code from Stack Overflow or on the internet, as that's what real programming is. You are going to have to memorize it later on, but it's just good that you understand how each of these work. Now, there's a very good video on this subject from Mr. Tom Scott, and I could have remade it, but I can't really beat him. He's very nice, so go ahead and show you the video. Let me just make the room for it real quick. Great. So what I want y'all to do is I'm going to post a link in the Funbox discussion, and you just want to go ahead and click on it. This is just a video sharing thing, since I can't share video over Discord without it being super laggy. So just go ahead and load into this. It's going to be like an 8-minute video. It has some fun animations, talk. It's all PG, so you don't have to worry about any of that. Yeah, it's going to start with no video since I haven't played anything. I'm just waiting for everyone to get in. So let's see, we got 1, 2, 3, 4, 5 people in. 1, 2, 3, 4, 5. Does anyone need any help getting in? Alright, I'll give you a few more seconds. So yeah, just watch over this, and I strongly recommend if you want something to watch that's educational, Tom Scott's always a good resource for it. Okay, I don't see anyone saying they need help. If you do, just type in and I'll help you. So just watch this video, it has some fun things. I'll add it too. Did that start playing for everyone? Did it not start playing for anyone? Okay, it did? Alright. And if it doesn't, you just want to click on the play and it should play for you. Alright, cool. So go ahead and play this.
It still says no for me.
Still says no video? You have to do it? Okay, is it gonna...
Just click on the link. Just close the tab and click on the link again. It'll do it.
Alright. Is it playing for you now?
Yeah.
Great. Alright, cool. Yeah, so now it's Mr. Tom Scott. Did the video work for everyone? Okay, I'm assuming it did. Yeah, cool.
Yeah, it worked.
Alright, great. So yeah, Tom Scott is a great educational resource. He has a bunch of interesting things on his channel. So yeah, that was just a quick overview of it. And the main thing, again, I want you to get out of this is not you gotta memorize sorting algorithms. It's just how you should try and find the best solution to it and not just stop at it works. So you can go ahead and close out of the tab once you're done. And cool. So yeah, next up we're just gonna do a quick Kahoot. Now I'm not good at Kahoots, so this is one that's super short. But let's go ahead and see if this works. Just a quick recap. How does it play? Alright, how do I screen share this? There we go. So, have all of you done a Kahoot before?
I have.
Alright, great. Yeah, so, Kahoots are, you can join at the kahoot.it. You just want to type in the code. Oh, I have no idea, bro. I was trying to come up with something. So you just want to type in this code. You can type in your name or whatever. It's just a quick mini game. It's not very long. Just go over what we've done so far. And if you need help getting in, you just type in chat. The game pin, if you look at the screen share I'm doing, you'll see the game pin. It's 2785632. And make sure you're watching the stream because I think you'll need that to answer it. Answer the questions. So if you're going to join the Kahoot, make sure you're doing it on your phone so you can still see the screen. got 5 people in so far. Very nice. Still waiting for 2 more. Oh, 6 people. Alright, who's not in? Let's see, guy. Camric, are you in? Or Karmic? If you need help getting in, you can just type in discussion. If I don't see anything in the next 10 seconds, I'm just going to go ahead and start the game, okay? Alright, cool. Oh, alright, let's start. And there we go. So you can see my screen for the questions. Not sure if you can hear the music or not. Hope you can. Cute music's always the best. Alright, yeah. Hello? Okay. Okay. Cool. Yep, so got that one. Nice. Mr. Dark's in the lead. Alright. True or false? Alright, so got 5 people and 1 person hit true. So yep, so like I was saying before, sorting algorithms differ based on case use, and there's many different ones that you can use. While there's some sorting algorithms you should never use, there's not one that you should always use. So let's see who's okay. Nitya is in the lead. So just think back. Cool. Yeah, so most of you got it. So bubble sort, like I was saying earlier, very slow, very inefficient, but also the most common that new people use. So this is why it's very important that you learn not to use it. Radix sort is actually a very fast one. It's kind of weird, so I didn't go over this. It's really mathematical intensive, but radix sort is still a good one to do. So who's in the lead now? We got Mara. Mara's in the lead. Alright, so yep, so cool sort, not an algorithm. Bongo sort, if you remember the Tom Scott video, he talked about it. It is an algorithm. So Amara's still in the lead. Coming up close. Nice, nice. Yeah, I think this is his last one. Alright, yeah, so I didn't go over this this much, so this was kind of a hard question, but yeah, so bongo sort is kind of a joke algorithm. So what it does, if you remember the video, it just randomly places them and sees and tells if it's in order. So if you want, you can even go on YouTube. There's like 10-hour bongo sort trying where it doesn't even get it right. Very, very inefficient algorithm. So who won? Third place. No, Jacob. Nice. Nice. Second place. And nice. Amara got first. Cool. And Dave and Dark were next after that. Alright. Cool. So that's a quick Kahoot on that. Give yourself a round of applause. Yay! Alright, cool. So, just wanted to go over that for implementing. Now, next up, we're going to do a bit of a coding one before we get into all the coding one for next time. So how many of you are familiar with recursion? Are any of you familiar with recursion? Cool, I'm assuming that's nobody. No worries. So that's what we're going to be going over today. So I'm going to be doing Python for this example, right? But this applies for every single programming language. So if you don't understand Python syntax, you don't have to worry about too much. Python is pretty easy to get, but I'm going to be explaining it. It's kind of more human readable code. So this is just a notebook file. Does everyone see it good? Where you can run Python code. Cool. So there's a thing called recursion, which is just when a function, so let's say def function, calls itself. So if we have a function, right, it says hi, and we call the function, it's going to print hi. And this is usually what we do for normal situations. But sometimes we want to call itself. So what if we have something where we take in a argument, so let's take in x, and we want to see if x is equal to 2, right? So if x is equal to 2, then we're going to print x is equal to 2. And if it's not equal to 2, we're going to call the function again with x plus 1. So we're going to call the function inside of the function. Make sure I put an else there. Alright, so what do you think will happen when I put function and a pass in 0 for x?
It will add 1 to x until it equals 2.
Yeah, exactly. So we can actually call it right here. Oh, wait, I got to, let's see what it's doing. Oh, I actually deleted the colon there. But yeah, so x is equal to 2, and we can actually print x to watch this happen. So go to 0, oh, not 2, so it goes again. 1, goes again. 2, oh, it's 2, so it prints x is equal to 2. And this, in normal programs, don't have to use this too much, but it's actually very useful for things like number sequences. So how many of you are familiar with the Fibonacci sequence? Okay, so Fibonacci sequence is a pretty well-known sequence. You may learn it as you get into geometry. Yeah, so it's basically where you start with 0, 1, and then you just add the location of the next number is equal to the sum of the last two. So 0 plus 1 is 1, right? So it'd be 1, 1 plus 1 is 2, 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 3 is 8, and it goes on forever. Now, implementing this into a program without recursion is very difficult, and using recursion actually makes it more, or actually makes it more understandable. So let's go ahead and begin by making a Fibonacci function. So if we just pass in, just number the Fibonacci thing, and we want to see so this is going to be where in it. So if we pass in like 2 or whatever, it's going to pass in at what thing it is. So for here, for example, number is representing the place it's at. So this is 0, 1, 1, 2, 3, 4, 5. So if the number is equal to 0, right, we can go ahead and say that we're going to return 0, because we know that the 0th place is always going to be 0. And the same thing for if number is 1, we can always return 1, because we always know that the first place, 0th place, first place is always going to be 1. But other than that, we can use this to just return the function call on itself, because if it's a number that's not 0 or 1, we can calculate the Fibonacci for it by just passing in the function for the Fibonacci of it, of the number minus 1. So if we're talking about here, it'll be the number minus 1, so this is going to be 1, plus the number minus 2, which is 0. Alright. So if we go ahead and do that, right, and let's say we want to pass in the Fibonacci for 2, right, it's going to give us 1, because the second thing we're starting for, so this is index 0, index 1, index 2, index 3, index 4, index 5. It's going to go here, and it's going to call itself to find these values. And this is actually great because we can pass in any number. If we pass in 100, it's going to run all the computations for it. May take a little bit. And things like number sequences can take a while because you're recursively calling this function a bunch of times, right? So actually, let's just make it a smaller one for now. So if we do 15, you can see it's 610. And we can actually print out the number to see how it's working. So if we do Fibonacci for 5, you're going to see it starts with 5, and then it has to call the Fibonacci number until it gets to the value that it wants. So, and then it returns up, and you eventually get back the numbers that you need. Does everyone see how this recursion is working? Here, I'll do a poll. It's in phone box discussion. You can go ahead and just do upvote, and if you don't, just downvote, and I'll go over it some more. Only got 3 votes on that. Is everyone good with it? Oh, okay, we got -1. So, Jacob, what do you not understand about it? And you can unmute your microphone.
Let's see. Oh, I lost it. I don't know. It's just weird with the Fibonacci number. Like, I don't know.
Okay, do you get how it, like, did you get the first example?
Yes.
Okay, yeah, so, the Fibonacci just relies on having the Fibonacci number of the one before it and the two before it to get whatever number you want. So instead of hard coding each number, we can come up with this schema which will generate them for us. So it actually has to loop through all the Fibonacci numbers to get this number, and then get this number, and then we can get this number.
Okay.
Yeah, does that make more sense?
Yeah.
Okay. And there's many more that you can do like this. So, for example, when you go into and you're starting to do more algorithmic or you're trying to speed up your program, you can make this use recursion a lot because especially for number sets, you're going to need to do it so you don't have to hard code everything in. Uh, cool. So that's recursion. Does anyone have any questions about recursion? Or have anything they want to talk about for that? Cool. All right. Oh, also Udin, you also had a question you want to ask? You can unmute your microphone anytime. Yes, this is for all programming languages.
Will these type of codes work for like the idle Python and like those running things?
Yeah, what Python?
The idle Python.
I don't know what that is.
It's one of the packages that comes whenever you download the Python running thing from Python.
Oh, is it like
And
an
basically, what
IDE?
it does is, yeah, idle. That's what I meant.
Oh, okay. Yeah, it'll work for all of Python. This is just, it's like another form of that, what I'm in right now. And this also works for Java as well, so I know you're talking about JavaScript, someone was, so quick JavaScript example. Great thing about JavaScript is you can run it anywhere, right? Is you can do the same thing. So you just pass in a number and do the same comparison. Oh, I hate the browser because I always accidentally hit the wrong enter. Yeah, and did you still want to ask your question, Ian? I saw you unmute your microphone, but you went back to mute.
Me?
Yeah.
No, I don't have a question.
Oh, okay, no problem. So like here you can apply the same thing for JavaScript, and you call the same what we do for this one. We called 5. So if we call Fibonacci 5, oh, we didn't return that. Always check your code. Return Fibonacci 5, we get 5, which if we check here is the right answer. So yeah, this works for all programming languages, and it's a great thing they can implement into your programs. It's a nice thing to know about. Cool. Any other questions about recursion or anything we talked about today? All right. So that's pretty much everything we got. So what I want y'all to go ahead and do is try and implement a recursion function in whatever language you know. So for some of you that's Python, JavaScript, Java, whatever you can open your programming language and just experiment around with it for the last like 7-8 minutes, okay? And if you need help, just hit me up. I'm gonna be here for you. All right. And y'all can unmute your microphone if you want to talk with each other while you do it. And if you have not already put in chat some programming language that you know or something you want to learn about them, you can do it so we can mend our next workshop to be more computer programming focused.
Are there any like websites or like YouTube channels that would be able to show us like if we wanted to learn more on our own time that wasn't in class? Would you suggest anything?
Oh, yeah, definitely. So, like I was talking about before, Tom Scott is a great channel. Here, I'll actually put him in chat. He has a lot of interesting computer science topics. He has a series called The Basics, which goes over a bunch of them. Most of his stuff is all PG. Um, Occasionally it's not, however, it'll be said in the title if it isn't. Let's see, The Basics, right? So this is a great playlist. If you want to learn, what are some other things you're thinking of about learning?
C++ and Java.
Java, okay. So, um, I'm pretty sure W2 Schools has a Java. Yeah, so this I learned some of my Java off of W3 Schools. If you look on the left, it has all these different things that you can learn, and you can just go through them whenever you have time. Like, it's very simple, easy to understand way of learning Java. It just teaches you really what you need to know. And it has pretty advanced stuff over here. Like, it even goes into lambda expressions, all that. Anything else?
Do you know any YouTube channels that teach Python?
Python. I think there's actually just a bunch of them. I know Colt Steele is. I learned Python from Colt Steele. I'm not sure if he has on YouTube.
Can you put a link in the discussion box?
Yeah, here, let me find one that's good. He has a course on Udemy, which is good. Free Code Camp is also great. So if you've never heard of Free Code Camp, it's an open source thing. So this is a long YouTube video, right? It's 4 hours long, but it has these little sections that you can just go one by one through. Now go over all of Python. So I'll paste this in. This is great. Your text editor is not opening. You may want to check that out. Who knows? Text editors are very fickle. All right. Yeah. So this is a great way. I watched I think 3 hours of this before signing off. That goes over all the advanced stuff, and you can actually just go on YouTube, search whatever you want to learn, and there's going to be someone there that can teach you. One important thing about programming, right, is finding where to get help. And a lot of times you can just search it up and there'll be someone like someone's talking about C++. If you type learn C++, there you go. Here's a 4-hour free code camp tutorial that goes over everything and has different sections. So I strongly recommend stuff like this if you want to learn. Does anyone else have any questions? Cool. Well, if you have any or you need any help while programming over the next week before our next one, feel free to message me. I'll get back to you as soon as possible. Appreciate y'all being here, and I'll go ahead and close this meeting out. So you're free to leave whenever you want.
Okay. Thank you.
No problem. Have a good day.
You too.